Problem number 3478. Choose k elements with maximum sum. You are given two integer arrays, nums1 and nums2, both of them n, together with a positive integer k. For each index I from 0 to n minus 1, perform the following. Find all indices j where nums1 j is less than nums1 I. Okay. Choose at most k values of nums2 j at these indices to maximize the total sum. Return an array answer of size n where answer I represents the result for the corresponding index I. Okay, so let's check the range of nums nums array. So yeah, can it be like the length? Can it be 0? No. Okay, so it is at least one element, and for each element it is at least 1, so it's positive integers. Okay. And it says for each okay, let's have this example. So it says for each index I from 0 to k, find all indices j where nums j is less than nums I. So for nums1, if this is for like, okay, so like I is 0, the value is 4, so j nums1 j is less than, so j can be like 1, 2, 3. Since 3 is 5, so we cannot choose it. 4. So it's like this, and choose at most k values of nums to j. Oh, like and then we use these j values to see nums to j to maximize the total sum. Most k values. Okay, so k is 2. So is it possible that maybe k, oh, it's at most. So yeah, if you have only 1, then you can only choose that value. So choose 2j index to maximize the sum. So we will choose for when j is 1, then it's 20. So okay, let's say if j is 1, it's 20, and if j is 2, it's 30, and if j is 4, it's 50. So and these are all positive, yeah, all positive values. So we will choose, yeah, if we can choose 2, then we should choose 2, like the most k, So we will have 2 and 4 as J. So okay, so answer 0 will be 80. Yeah. Okay. So I think, yeah, like we cannot sort since the J index, the index matters, so we cannot sort its value. Yeah, but we have to yeah, like we have to find a method that can easily find value that is smaller than the nums 1i. We can still sort, but like sort with its, let's see, okay, it's n is 10 with the power of 5. We can sort and sort with its index, so that, yeah, like maybe we can have like 1, 2, yeah, like this is the value and the second will be its index, and the next one will be 2, 1, and 3, 4, and 4, 0, 5, 3. So yeah, but we should be faster to locate. Okay, it's so now if we see this 1 and its index is 2, so minus 1, so we'll have J. J will be nothing, like since there's no other if there is no other J that is less than itself, then we will be 0. So J will be negative. Then nums 2 will have, like 0. And answer will be 0. And then for this value is 2, so J is the one that is before, so J has 2. And this will be like the previous and itself, like this itself and its value, so we'll have 2 and 1, and this will be 4, 2 and 1, and this will be this its previous and 0, 4, 2, 1. And okay, so we need faster to choose the sum. Oh, is it better like yeah, if I also do norm to like this, so it will be 50 yeah, like 50, it's 4, or yeah, I want to use like I'm finding a way to quickly get the best value, the maximum sum. So I think it would be like yeah, if J is a set, then we can sort by value, and this is value index, and this will be set, and yeah, like but oh, but this is adding, don't need set. Yeah, like if you have two now, then this will have 2. So yeah, so for I think this is 0 and 2 will be 2 will be 30. So this is definitely having 30 plus 1, 20. And then it's 50. It's yeah, like yeah, there's 50 here, and yeah, like every time when we add a new value, we should check if it is larger than the current yeah, like when having 4, we are adding 50. So like for nums 2, we can have k size max heap, so that every time adding a number, then yeah, like when adding 4, we can check the current large. It's 30, and 4 it's 50. So 50 is larger than 30. So yeah, then we can we add 50. Yeah, I want to delete 20 now. Let me think. So or a min heap, maybe a min heap, so that when max heap, when we add 50, but we cannot pop 30. So a min heap. So when we add a new value, when we add 50, you can add and it will pop 20. So, and for this, so it will be 50 plus 30. And when adding 10, it will pop. We'll first add and then pop. So it will still be 50 plus 30. Okay. Yeah. So that will be time complexity. I'll say sort will be O n log n, and J for calculating J, it would be n, and for calculating nums 2, it's a min heap, so it would be n log n. So let's start. First have sorted nums, so sort. Yeah, we'll create another like sorted say nums one index, and we will have for I value enumerate nums 1. So we'll have value and I, and then we will sort okay, let's keep it sorted with the first value and okay, and J's. Yeah, I'm thinking of the data structure for J. Or we can just loop through nums 1. Yeah, maybe we can just loop through nums 1. So it's for value and I in nums 1 index. It's sorted now, so yeah, we'll have a heap for sum. So let's have nums to sum. Will be a k-size min heap. So if okay, so the first I will be 0. So we will have to create answer. It will be okay. Let's have n first. N is the length of nums 1, and answer will be 0 multiplied by n. Okay, so for I, so answer I think we will start from, yeah, I would like to start from the the pre one, like index. Okay, if I is 0, let's continue. And then so now J will be yeah, we need to I think we don't need to store the J, since every time we add a new value, then we can check the heap. Okay, so let's check if heap, well, the length of nums to sum is larger than k, then that's pop. Then hit pop, nums to sum. Okay, so now the size of nums to length sum is smaller or equal to k. But we should first add, then so hit push nums to the previous nums to it will be the value before. I'll have this, and let's have, I think we'll have index will be yeah, this is not okay, I think I will have n, and let's have I, and yeah, range, and let's start from 1, and okay, so hit push okay, so 0 will be this, so it will be value and index. And we will use this index I think we only need the previous, right? Because previous will be the j. Okay, so so for nums 2, it's j will be in, this is index, and do we need the value? No, I don't think so. Yeah, and okay, I'll say j, then it's easier. Nums to j, then pop if it's larger than k, if the length is larger than k. If no, okay, answer will be answer j. Okay, it's a bit confusing. So value and index, let's have index. Sorry. And this index will be used as here, and no. we will have the current index. The current will be I'll say proof index. Like this value. Yeah, I'll say J. I'll say primary index. Okay, so yeah, and then we'll have the current one. So it will be value is not say index. Okay, it's lagging. Sorry. Wait a second. So this index, yeah, the current index will be as the previous index plus yeah, I don't know the sum. Yeah, if I always sum up, yeah, we can still do like this. Oh, but it will be n with, yeah, that's n with the power of 2. It's gonna be too much. But yeah, I think, okay, so if I want to write if I is 0, then insert index no, we don't need. Okay, so I'm kind of want to figure out, is there a better way to calculate the sum? Hip hop. Okay, so answer in, if hip hop, then that means we need to okay, so I should minus this value. So when I push, then I should add, like for this, I would first add 50, and then when pop, I will minus 20. So it can be like equals the previous index value plus the current, and then minus the pop value. Okay. Then that's return answer. Oh. Then we should add nums to sum here. Let's see if, we should compare the value. We cannot, since it's all equal, we did not compare. So only if these two values are not equal, then we can select its index, right? So let's have a pref value and value. So if value is larger than pref value, I'll say if value equals pre-value, and that's continue. We should not use its index to find. Let's print the sorted nums index and see what's going wrong. So okay, so we are starting from this. So the zero part are all, no, this is correct. So 1, 2, 0. Okay, this is correct. Okay, when this value, so we have 9, 3 and 7, 6 here. If okay, 9 is 9, okay, they will not continue. So we will push the previous index. Its pre-index is 6. So 6 it's 23. Yeah, 23 is pushed. So answer will be, the previous index is 0. So 23 plus 0. Yeah. So it's 23. Correct. Well then, no, it's now k is 1 and now length is 1. Okay, so we will not go into this while loop. Okay, so move on to the next. I will be now 2, so it's now this one. So it's 9, 3 and 10, 4. Okay, so we'll not continue. We are not equal values. Hip will push 3. 3 will be 4. Okay, and then so prev is 23. 23 plus 3, 23. Yeah. Oh. 23. 23 plus 4 is 27, but then 4 will be out. So yeah, hip hop, it's mean, so it will pop 4. So it's 23 again. So for 4 it's 23. Yes. Okay, these two are correct. Then we will move on to this 11. 11 is not equal value, so we will push 4. This index 4 is 2. So the previous value is 23. 23 plus 2, 25. 25, but okay, it will go into this while loop and then pop 2. So it will be 23 again, and it's index 1. So yeah, it's 23. Okay. Next move on to this 11, 5. Okay, so I think maybe it's, yeah. Yeah, I think it may go wrong, it's here. So when we met, because yeah, we need this 6, 3, 4, so we cannot just continue. we cannot use, we will not add, but we will not perform this and this. So I think we'll have the previous index like this. Then else we will do push and those stuff. Oh, it's still wrong. But well, this is now correct. Only 0. Okay, let's see. So 11. Before it's 23, right? And so it will have 23 again. And then move on to this 16, 8. So previous value will be 11, 5, 16, 8. So 16 is larger than 11, so we will not go into this condition. And we will push 5. Nums 2, 5 is 2. How come I think we already have 2? Oh, sorry, 19. So it's 19. So we push 19, and 23 plus 19 is 42, but it's larger than k, so we will pop. We'll still pop 19 since we already have 23. So it's still 23. So 8 will be 23. But why it's 26? How come? One. Oh, it's because I didn't like. Okay, so when it met an equal value, there is something. When these two are equal, I cannot use its index, but when this is now for the next value it's larger, and can use both of these values. So it adds 5, but it did not add 1. I'm thinking can I first push, but I will not add, okay, so Yeah, we will not add since we are equal, so we will not if we are equal, that means the maximum will be its previous, it's the same. So this will be if value is larger than pre-value else 0, like this, and this is also yeah, since we did not add, we cannot pop. So it's also like this. Okay, still not correct. Maybe that's print hip. Yeah, I'm not really sure what's going on. Yeah, it changed to 26. How come this is not 26? previous. Is that because previous index will be 23? Because norms to proof index 5 is 19. Okay. I know where's the problem, but to check. Okay, I think it's better yeah, I think I'm in the right direction, but like the sum will, it's not too easy to calculate. Like I think I will still have a sum. Like max sum, and it's 0 at first. So every time I push, it will be max sum. This, and every time I pop, it will pop the will minus the pop value, and then answer index will be okay, if it will be max sum if else is previous sum is answer prev index. Maybe this is better. Like this. Okay.